You ever wonder how the most amazing things in our world actually get made? You know, the cars, the planes, the gadgets we rely on every day. Well, behind almost every major innovation, there's a kind of hidden architect, a company working in the background, literally designing the future. Today, we're going to pull back the curtain on that company. So let's start with a little riddle. Take a look at these three things. You've got a super advanced hypercar, built for nothing but speed. Then you've got this futuristic, all-electric air taxi. And finally, a pair of high-tech running shoes. I mean, they couldn't be more different, right? But believe it or not, they all share one incredible secret.
And there it is. Before a single screw was turned or a single piece of fabric was cut, all of these products had already lived a full life. They were tested, tweaked, and perfected down to the last detail, as digital copies of themselves, existing only inside a computer. That's the power we're talking about.
Okay, so who's building these incredible virtual worlds? The company is a French software giant called Dassault Systèmes. And chances are, you may not have heard of them. But for decades, they've been the invisible hand, the hidden architect, guiding the creation of the most complex products on the planet.
And when I say giant, I mean it. This is a company that started way back in 1981 as a spin-off from an airplane manufacturer, of all things. Now, they're a global powerhouse. We're talking 25,000 employees, offices all over the world, and revenues well over 6 billion euros. They are the undisputed leader in this space.
But to really get why they're so important, we have to go back in time. Back to a project that was so ridiculously ambitious, it completely changed how we make things forever.
So, back in the 80s, their main software was this 3D design tool called CATIA. They teamed up with IBM, which gave them this huge global reach. But the real aha moment, the big breakthrough, came in the 90s when Boeing took a massive gamble. They decided to design their brand new airliner, the 777, using nothing but CATIA.
Think about what paperless meant back then. It meant no physical prototypes, no giant mock-ups. Every single one of that plane's millions of parts was designed, fitted, and tested digitally first. The result? It worked flawlessly. It slashed errors and expensive rework. It was this huge success that proved to the entire world that this was the future.
And this idea, the technology that made the 777 possible, is what they now call the virtual twin. Now, it's super important to understand, this is not just some static 3D picture. Oh no, it's a living, breathing, dynamic simulation. You can see how it handles stress, heat, airflow. You can simulate its entire life before it even exists in the real world.
And this just lays it out perfectly. I mean, look at the difference. The old way was all about building expensive, clunky, physical prototypes one after the other. It was slow and wasteful. The new way? You build one virtual twin and you can test millions of possibilities almost instantly. You can fine-tune everything for performance and cost before you spend a single dollar on materials. It's a total game changer.
But creating one amazing tool wasn't the end game. No, the vision was way bigger. It was about creating an entire virtual universe where innovation could happen.
And that vision became a reality in 2012 when they launched the 3D Experience platform. The easiest way to think about it is like an operating system, but for creating things. It's one single place where everyone, designers, engineers, marketing, managers, could all work together on the very same virtual twin, all at the same time.
So here's how it generally works. First, you model your idea in 3D. Then you simulate it to see how it's going to behave in the real world. After that, you plan out the entire manufacturing process, all virtually. And the whole time, everyone can collaborate, managing the project from start to finish. It's this complete, seamless workflow.
And having this incredible platform allowed them to dream even bigger. They could go from just designing products to modeling entire complex systems, including, well, the most complex system we know of, us, people.
So let's jump back to that riddle from the beginning. That hypercar, that's the Peugeot 9X8. They used virtual twins to test and perfect its aerodynamics entirely on the cloud. I mean, imagine the time and money they saved compared to building physical models and using wind tunnels over and over again.
And that air taxi, that's from a company called Joby Aviation. Now, for something as insanely complex as a flying taxi, you need what's called a single digital thread. One master file that connects design, manufacturing, and all the tough safety certifications. The 3D Experience platform is that thread.
And yep, even your running shoes.
ASICS uses virtual twins not just to design better, more customized shoes, but they also use it to show you, the customer, all the cool tech that's going on inside the shoe, so you can actually see what you're buying.
But here's where the story takes a truly mind-blowing turn. The company's focus has shifted from just things to life. They are now taking everything they've learned over 4 decades and applying it to the human body itself. And what this means for medicine is just wow. Take the Living Heart Project. It's a scientifically perfect virtual twin of a functioning human heart. Doctors can use it to test new drugs and medical devices safely without any risk to a patient. Their Medata platform helps manage thousands of clinical trials, and pharma companies like Sanofi are designing entire vaccine factories in the virtual world first. So how big is this whole ecosystem? Well, the number is pretty staggering. Right now, there are over 25 million people, engineers, doctors, scientists, designers, in 140 countries all using these virtual worlds to invent our future.
So what's next? Well, as you can probably guess, that line between the real world and the virtual world is getting blurrier every single day.
The next big leap is something they're calling 3D UNIV+RSES. Basically, they're embedding industrial-grade AI right into the virtual twins, making them smarter, more predictive. And they're working with companies like Apple to bring these super complex simulations into the world of spatial computing, so you can interact with them on devices like the Vision Pro.
And all of this leaves us with one final fascinating question to think about. For years, this tech has helped us build better products. Now, it's helping us understand our own bodies. So if we now have the power to simulate and perfect almost anything in a virtual world before we build it in the real one, what's the next great challenge we're going to solve?